Hi, I'm going to talk about derivatives. You want to know a bit more about derivatives? Let's start with somebody's given you a function, and you may already know some of the crazy rules that you do with these things called derivatives, where perhaps someone's given you a function, it's x to the power of something, and they say, what's the derivative? And that looks like, maybe they write it like this. And the way you work that out is you do some funky stuff. You take the power and you minus 1, and then you multiply that by, well, the power, and you also multiply it by the derivative of whatever this x is. Actually, it's all a bit weird, but that would be 1 in this case. But what exactly are you doing? You don't really, it's a bit confusing, right? Okay, so you could have a function and it's x raised to the 5, and therefore derivative equals x raised to the 4 times 4 times 1, so that equals 4x4. Look at that, you got the derivative. That's exciting because you followed the rules and you got that. But do you have any idea what a derivative is? It can be really hard sometimes to sort of remember what you're supposed to be doing when it doesn't mean anything. So it's pretty cool to know what it actually means. So a good way of understanding what it means is to actually look at a graph. And so let's say our graph is about time. This could be, our x-axis could be time, and over a period of time, maybe 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, something is changing over this period of time, which gives us our y-axis. Could be anything. Maybe it's the speed of a vehicle or something over time, or maybe it's the temperature of our coffee. Okay, we've made a cup of coffee and we're measuring the temperature over the time as it cools. I guess it's going to cool. So I'm thinking it's probably really hot to start with. It's up here at some temperature. I don't know. It's hot, okay? And it starts off hot and it cools. And it cools and it cools and it cools. I've decided it cools this way. I don't know if that's really the way it cools. Maybe it actually cools this way. I'm not sure. In our case, we've decided this coffee is going to cool like that. Okay. So, what does this have to do with derivatives? Okay, what's this crazy woman on about? Okay, in this particular case, let's say this function y equals f of x. So a function of x at any given point gives us a value for y. And that's how we get every little point on this graph. That's how we get this line. So the derivative, this weird thing, what is that? Okay, that is a tangent, the gradient of a tangent at a point. So let's pick a point and then we'll get a bit more detailed and then it might become clear as to what that is. So we're going to say, we're going to be specific, and we're going to make x equals 2. So if we do that, then we pick a point, it's at x equals 2. So at that point, this here is the gradient of this line here. But why? Why is it so? Okay, there's actually a reason for it. The gradient of this line is telling us some information about what is happening on that curve at that particular point in time. So at 2 minutes, if we look at this function up here, we say the function at 2 equals, whatever this equals, warm. Let's say it equals warm at 2 minutes. So what we're saying is at 2 minutes, the coffee is warm. It's no longer hot, it's warm, okay? But we want to know exactly at what rate is it cooling. So we know up here it's cooling, at here it's cooling, and here it's cooling, but at each point it's cooling at a different rate. So, for example, when it's cooling here at approximately 1 minute, if we look at the tangent gradient there, whew, that's steep. That is steep. So at 1 minute, it's cooling rapidly. It's losing more temperature per minute at 1 minute than it is at 2 minutes. And if we were to look at 3 minutes, by chance, it's a shallower line. It's a shallower gradient. So what does it mean to have a shallower gradient? It's not as steep. It's not steep. So the temperature of the coffee is still cooling, and it's definitely cooler than it was here or here, but it's cooling at a lesser rate. So it's not getting cooler and cooler as fast as it was up here. And we can tell that by the gradient of that line. And the gradient of that line right there is the derivative of that function at x equals 3.